Okay, class, so today we're going to talk about piecewise functions, okay, and how to graph them. So piecewise function is a function that includes multiple rules or multiple functions within it, and that if taken all together gives you the total function, okay? And so that's why we call it piecewise, because at each interval the function behaves differently, okay, based on a different rule. Okay, so up to this point we've dealt with, hey, a function is equal to this, it has one rule, and all x values go through that machine, right, the function, and comes out. Well, now we're going to split it up into different intervals and say, hey, on this interval the function behaves this way, but on a different interval of the domain the function behaves another way. Okay, so let's use these as an example here. So in this example here, I've got two piecewise functions. So A, we have this piecewise function, so it's defined on two different intervals. When x is less than or equal to 2, this is the rule for the function. But when x is greater than 2, this is the rule for the function. And so now how we're going to graph this? Well, first of all, we split this up into two different intervals. So for less than or equal to 2, so from here to the left, it's going to behave this way. Okay, so if we look at this, and again, it might help just to create a table. Okay, right? And so when x is, let's say, -4, okay? When x is -4, I get -8 plus 5, so that's going to be way up here, so I don't want that one. Well, let's start with 0. Let's just start at, let's start at 2. Let's just go 2 and see what happens. And then go to the left. So we're going to go 2, 1, 0, -1, -2. Okay, so at 2, what's the value? So at 2, this is going to be -4. And then 5 minus 4, or -4 plus 5 is 1, so that's going to give us a 1. When x is 1, we get 3. When x is 0, it's going to be 5. And then when x is -1, we get 8. So notice what's happening here. Okay, so it's going up by what? Oh, hold on. Did I make a mistake here? 1, 3. Yeah, okay. Okay, 2. Okay, so hold on a second. Something doesn't look right. So 2. So, that's it. Oh, wait a minute. 2. Yeah, that's right. 4. So that's -4. And then 1 gives me -2, which gives me 3. 0 gives me 5. -1 gives me 3. Hold on. -1. And then 2. So -2. Oh, right. This is 7. That's right. Okay. There we go. So it's going up by 2. I knew that was strange. Okay, so this goes up by 2's, right? So now we can plot this. Now from 2, so at 2 it's 1. So let's do that. So let's plot at 1. And then at 1 it's 3. And then at 0 it's 5. So that'll be up here. So what we can say is if we do this, let's plot these here. It's going to do something like that. Okay? So it's going to keep going up. It's a straight line, right? It's a straight line, and it's going like this up until 2. Now notice that I'm going to put a solid dot there. Why? Because it's equal. So at 2, it's equal to this. So now also what happens is it changes at greater than 2. Now we're going to be here. So what happens here? At 3, what's the value of y? So at 3, it's going to be 4. So now at 3, I'm going to put at 4. But notice I put an open circle. Okay? So I put an open circle here at 4. And now what's going to happen here? Well, now it's going to go up by 1, right? So this is a straight line 2. So when x is 4, it goes to 5. So let's say it's up here. Right down there, right? And so now I'm going to continue this way. And so now, oh, hold on. I made a mistake. Nope, that's not an open circle. 2. So if I stick 2 in here, now even though 2 is not in the domain, I'm going to stick 2 in here because it behaves this way up to 2. So if I stick 2 in here, I'm going to get 3. So that means, oops, wrong marker. I'm going to have an open circle at 2, 3. There we go. And then my line does this. Okay, so now what happens is from 2 to negative infinity, it's going to behave like this. And then at 2, it jumps. Because what happens is now we're under this rule here, and at 2, it jumps to 3, but now it's an open circle because we're not including 2 in the domain of this part. Okay? So it's not included in this interval, so we put an open circle there. So now we've got it graphed. So now we've got the graph of this piecewise function. And notice that the domain is all real numbers, even though we have this open circle, but it's covered here. Okay? So if we take all the x values, we're good. There's no restricted x values. Okay? Now, the range of this function starts at 1 and goes up to positive infinity, because that's where all the y values are. Okay? And so is this continuous? Well, it's continuous everywhere except at x equals 2. So there's a discontinuity at x equals 2 because that's where it jumps. Okay? It is decreasing from negative infinity to 2 and is increasing from 2 to positive infinity. Okay? So again, but the main part is, hey, this is how we graph a piecewise function. Okay, so let's do another one. Let's do this one over here. So again, let's see what happens at 0. Okay? At 0, this is going to be 3. Okay, now since the equal sign is here, we're going to put a closed circle at 0, 3. So 0, 3, we're going to put in closed circle. Now here at 0, what happens here? You have 3 as well. So in this example, you get the same value. So we're good. So this is going to be where they both meet. Okay, so there's no jump in this graph. Unlike over here, we had a jump. In this case, the value of both of the functions at 0 is the same. Okay, so we're going to have a point here. Now, for less than 0, let's see what happens. So at -1, we get 1. So -1, right? So just double check. So -1 gives me -2, plus 3 gives me 1. So at -1, 1, we're going to have that. And then at -2, we're going to get what? So if x is -2, we get -1. So at -2, we get -1. And then again, you could use the slope too, right? So it's going what? It's going up 2 over 1. So we could go down 2 to the left 1, okay? But I think we've got enough points here, so it's going to be, oops, like this. Okay, so let me fix my point here. Okay, so there's this piece, right? So notice that it does this up to 3, right? Or excuse me, up to 0. And so this is the first piece. Now, what happens here? Well, now, we know it's 0, it's going to be 0, but what happens at 1? Well, let's plug in 1 here. 1 squared is 1, negative of that is negative 1, plus 3 is 2. So this is going to be 1, comma 2. So 1 comma 2 is going to go right here. Okay. Now let's put in 2. Well, 2 squared is 4. Negative 4 plus 3 is 1. So this is going to be 2 comma 1. Okay. And then 3. 3 squared is 9. Then the opposite of that, or negative of that, is negative 9. Plus 3 is negative 6. So let's see here. Hold on a second. Let me make sure I'm doing this right. So 1 squared is 1. So that's going to be 2. So 1 comma 2. And then 2 squared is 4. Negative 4. So that's going to be negative 3. Oh, hold on. Or negative 1. Oh, that's what I did. So it's going to be 2 comma negative 1. Knew that wasn't looking right. And then this is going to be 3, and then this is going to give me negative 6, which is, let's say, way down here. So that's going to be 3 down here. And so what's happening here is it starts at 3, and it looks like that. So it's not a straight line, but it's an upside down parabola starting here. Okay? So it's a straight line this way, so it's linear from negative infinity to 3, and then it turns into a quadratic. Okay? And that's how you solve this, or graph this one. So notice how in this case here, we had a jump in the graph, and over here, we didn't. They actually met. So in this case here, this is continuous. So this is a continuous graph. Okay, a continuous function. So we would say this is continuous. This is not continuous. Okay, on the whole number line. Okay, so again, so what's the domain? The domain here is all real numbers. The range is going to be from 3, so square bracket 3 to negative infinity for the range. It's increasing from negative infinity to 3, and then from 3 to positive infinity, it decreases. Okay? And then it's continuous everywhere. And that's it. So that's how you handle piecewise functions. Okay? You got to just graph them piece by piece and then put it all together. Okay? So again, be careful. Make sure you put open circles and closed circles when necessary. In this case, we didn't need to do any of that. Okay? Have a great day.